Right, hello to my year 6 this time for a video on acids and alkalis. We've done some things in class, we've done a lab on these things, but also what we are going to do is give you some basic knowledge here in this video, and we're going to look at why they're important to the environment, to society in class, so you need the knowledge before you come. And it's going to be a bit different this time. If you go under this video, down here, if you're on SchoolSoft, you will find a link to a Google Doc form. Google Doc form. And you can take the checkpoint online. So have a go at that checkpoint online. Make sure you know the things before you come to class. We'll change it around this time, make it even better. Acids and alkalis then today. They can be dangerous. Very strong and very weak, very strong acids and very strong alkalis can do significant damage to the body, internally and externally. The problem is that they are very good at corroding things. They say fläta på svenska. And if something corrodes, it's able to break it down. It's able to destroy the tissues of your skin, some of those that are inside your body too. Too much acid and alkali can be very, very dangerous. So you have those sensations, the burning, the breaking up of the skin sensations. But even weak acids and weak alkalis can be a problem too. And the big example of this is food. Nowadays we eat a lot of sugary food, lots of bacteria make acid on our teeth, lots of fizzy drinks, lots of acid in there, lots of things like citric acid that are very tasty, but have the problem that they are acidic. And lots of food can also then mean after a long time our teeth can get damaged. So protecting our teeth is something very important as well. We need to make sure that we moderate how much acid goes into our teeth, or limit how often we have acid on our teeth. Don't have too many fizzy drinks or snacks, for example. Now, the thing is, how do I know if something's acid or alkali? Because yes, I can taste it, but if I taste it, then it might do me a lot of damage. So we don't taste things. Now there are different things we can use called indicators. Indicators are things that do different things in acid or alkali. And most often they change colour. So it's really simple. You're able to see a difference in colour if it's an acid or an alkali. And some of these can be simple. We have litmus paper, very famous, we'll use it in the lab. And litmus actually comes from lichen. It's actually a biological thing. Red cabbage, root call, can also be used as an indicator. It actually also changes colour. Now, all of these are different rules in how they work. Some change colour in acids, some change colours in alkali, some turn purple, some turn pink, and so on. They're all really good, but we actually made something even better. We made universal indicator. Basically, it's lots of different indicators put together. And that can tell me more precisely and more exactly, not just if it's acid or alkali, but tell me exactly how acidic. So it has a complete range of colours. Now, there are many different types of universal indicator. Usually comes again in a small paper, but there's the classic one, the one from your spectrum books, which is the one I'm going to use myself to go through as the example for you all. So it starts off with things that are strong acids, and they are red, going through to what we call the neutral objects. I'll come back to that, but they are green, and then those that are strong alkalis usually turn purple. And of course there'll be blue in here and yellows and oranges in here, but this is your basic pattern: strong acids, neutral to strong alkalis. And this is what we discussed when we talk about universal indicator and the colours. So I can tell if it's a strong acid, neutral, weak alkali, strong alkali. It's even better. But also, I can actually look in even more detail and put some numbers to how strong my acid or alkali is too. I can use something called pH. Small p, big H. It actually means potential of hydrogen. But you don't need to know that, so it's okay. pH will do. And if I put neutral, so back to neutral, and that's at a pH of 7. 7 is, for some reason, the neutral number. I don't know why either. The strongest acids are 0, and the strongest alkali is 14. It goes from 0 up to 14. If every single thing in your liquid is an acid, then it's going to be 0. You can get very close to 0. It's very unusual to get something so low, or even possibly lower. But wouldn't be doing anything lower or higher than these in what we are studying at school. What is important here to know is maybe to use this to try and work out a maths. If I have something maybe at 5 here, yeah, and I have something at 13 here, I need lots more of the 5 to make this go to neutral. Because of course I can make acids and alkalis become something neutral. I can do something called neutralization. And what neutralization is the idea that I can make my acid and alkali combine together, and that neutral thing, that thing that is perfect in the middle, is actually water. Water is perfectly neutral. I also make, when I do that, I make a salt. It could be the type of salt you have on your fish and chips. It could be that horrible, disgusting type of salt you Swedish people put on your sweets. Or it could be a different type of salt. There's many different types of salts. But a salt and water are made from acids and alkalis. That's neutralization, and what I will be expecting the top students to do is maybe to be able to name acids and alkalis when they go up to the higher levels in school, and of course what the water and therefore the salt would be called, and how many atoms and so forth afterwards. That is the basics of acids and alkalis for now. In class, what we'll do is we'll look at why this is important, how it affects society, how it affects the environment, and you guys need to go down here and do a little test. Thank you. Have a great day.